Alright, chemists, here we go. So we're going to start with a little bit of work on qualitative analysis of ions, and then after this we'll move on to how to do it quantitatively in the next lesson. So these are our dot points here. Um, Essentially, this will provide a summary or a method for how you are to do this dot point, which is to basically work out, using a range of tests, which ions are present in some various unknown solutions. Alright, so you want to be able to show that you understand that a qualitative analysis allows us to identify ions in substances, but not really how much of it there is. So, like, there are some where we'll be able to work out that it's above a certain level because it won't actually, like, the tests aren't sensitive enough to detect it beneath that, but that's about as good as we get. So we can do this with a variety of different things, and it's generally allowed for used for either quality control or testing the presence of um, ions, particularly metals and phosphates, in waterways, soil, biomedical testing, stuff like that. All right. You should also, by the end of this, be able to produce a flowchart that describes a method for testing for anions and cations. And you need to be able to explain that flowchart with a bit of detail. So, what do you need to remember? You need to remember, for starters, that a cation is a positively charged ion. So it's one that's attracted to the cathode in electrolysis, and these include, for example, barium, calcium, lead, copper, iron 2, and iron 3. Um, an anion is a negatively charged ion, so it's attracted to the anode in electrolysis, and the ones we're concerned with are phosphate, sulfate, chloride, carbonate. And also, particularly as we talk about solubility rules, anion plus a cation gives us a salt. Now, types of tests. So first off, and the simplest one you've been doing for probably 4 years now, is the flame test. Um, it's really used for metals, and based on the emission spectrum, we can work out which metals are present. Standard reactions. Now, this just means this is not a formal category. This is just what I've put in to show you, to remind you of some of the other ways to do it. So these are distinctive, simple chemical tests, ones that we've done. So if you were testing for hydrogen, there's the POP test. But if you're testing for carbonate, one thing you do is react it with an acid, which will give you carbon dioxide. Now, so it will effervesce, it will give you bubbles. And the way you know that these bubbles have carbon dioxide in it is you bubble it through lime water and it'll turn it milky. So that's pretty straightforward. Precipitation reactions. Some salts, and this is actually the most common one, will precipitate out of solution when formed. Now, while we're doing this, it's very important that you need to remember to do confirmation tests. So this is a secondary test which we would conduct to validate our original findings. So here we have our solubility rules. You should get this down too. So, for example, sulfates are soluble unless it's silver sulfate, lead sulfate, mercury sulfate, barium sulfate, and so forth. Our carbonates and phosphates tend to be insoluble unless they're mixed with a group 1 metal or ammonium. Hydroxides, again, tend to be insoluble unless it's ammonium, calcium, barium, or group 1 metals, and so forth. Alright. Alright, so let's test for an anion. We're going to use the US to stand for unknown solution there. And the first thing we do is we test for carbonates. So you test for carbonates, and the order here is actually important. With anions in particular, the order is important. Please get the order right, and we'll see why in a second. So you want to test for carbonate. So your first test you'll do is you'd add nitric acid, 2 molar nitric acid, and you check for carbon dioxide. So we see here when we add the hydrogen to the carbonate, we get carbon dioxide and water, and you do this, look for bubbles and then lime water. You want to confirm it by testing the pH. If the pH is between 8 and 11, it's got carbonate, or that plus the other one means it's very likely that it has carbonates in there. And you can see why here. For then you want to acidify the unknown solution a bit more. Okay, this will remove excess carbonates. So you see why you want to do carbonates first, um, because barium carbonate is also insoluble. So you test for sulfates by adding a barium solution, barium nitrate, something like that. And when you do that, you get solid barium sulfate. You confirm this by adding lead nitrate to the acidified solution, and this will give a white precipitate. So lead sulfate is a white solid. You see that there, sulfate plus the lead gives that. Now, to test for chlorides, you want to again acidify the original solution, and you want to add silver nitrate. Silver nitrate, this goes from chlorine ions plus the silver ions gives you silver chloride, which is a solid, as we've done before in precipitation tests. You can confirm this by adding ammonia and heating it in a water bath. And as we do this, the precipitation will dissolve, and that's pretty cool too, as we go back to chloride ions. Then when you want to test for phosphates, this is the last of the anions we have to look for. You alkalize either the original solution or the filtered solution from the previous step. So you filter out filter that step out, and you add barium nitrate. So you alkalize it by adding ammonia, okay, enough to get the pH down, up to about 11. Then you add barium nitrate. Now, this here, it gives us, so this tests for phosphate, by giving us barium phosphate. Cool. You want to confirm it by adding silver nitrate to the original solution, and you'll get a yellow cloudy solution, a yellow cloudy precipitate. So here it is as a flowchart, and you'll notice, so anion unknowns, we add nitric acid. If it effervesces, we've got CO2. No effervescence, we continue on. What you'll also notice is that there's none of the confirmation tests are on there. So when we write out our flowchart, none of the confirmation tests are there. All right. This is a summary of our test for cations. Okay. So you'll notice that there's 2 for each of them, with the exception of lead. If we've got good reason to suspect that lead is there, it's probably best not to do a flame test in general. So we're not putting that in there. But you can, flame test, add sulfate for barium. Flame test, add carbonate for calcium. So these are just some examples. But when we go on to the next slide, we'll actually have a step-by-step one. It's actually from your textbook, and it's pretty much the best I can find of a really succinct and good one. Good examples to go for. All right, so this is how you would test for cations. So first, you would go in this order. You would have test for lead. You'd add your 5 drops of dilute hydrochloric acid. Okay, and this will give you a white precipitate. Now, you want to do this in cooler water, because this will, dissolve out. So it won't form the precipitate in hot water. All right, so you want to confirm it. All right, so you add some sodium iodide into the solution, and you'll also get a yellow precipitate. Now you'll see that you could actually do either of those; it wouldn't make a difference. This one's a bit trickier. Okay, so first off, for barium and calcium, you'll notice that they're put together. You'll also notice that they're from the same group in the periodic table. This is important. So we can see that the trends in the periodic table, the reactivity trends carry through. Okay, so fresh sample of solution or filtering it out, your call. You add about 5 to 10 drops of 1 molar sulfuric acid. Now, a white precipitate will form if either of these are there. Okay, so if either of them are there. Now, we need to know which one it is. So we add solution of sodium fluoride. Now, white precipitate forms if it's calcium, no precipitate forms if it's barium. The reason we didn't do this in the first place, okay, if that's the one that differentiates, is because there's no precipitate for barium. So we could get a false negative. So we have to do this one here first. Alright, so add the acid, cool, the sulfuric acid. It's not just any acid, sulfuric acid. So we add the sulfuric acid, sweet. We find that we get a solution, and then if that comes up one, we add sodium fluoride, which gives us calcium fluoride solid. If it's calcium, nothing in solution, nothing in precipitate if it's barium. Now, you can then get the original solution and you can do a flame test as well to confirm this one. Okay, and it's important that you confirm this step here because if it's too dilute, you might not get a positive here either. So that one's important. All right. Now we want to move on to our next step, which is to test for copper, which we're going to add some sodium hydroxide. All right, cool. So we add sodium hydroxide, and we get copper hydroxide solid. All right, this is for copper 2+. We'll get copper hydroxide solid. Then we'll add some ammonia to it, and the solution will disappear. Okay, so it will reionize, and that's important. So that test for it being copper hydroxide, copper 2. Green flame test indicates that it's a copper ion. So that's our confirmation test, greeny blue. All right, for iron, now we'll add sodium hydroxide, and you'll notice that iron, it will form two different ions here. Sorry, had to pause. Just starting to chatter a bit too much. The teeth were chattering. So, brown precipitate will indicate that it is Fe3+. However, interestingly, if you have Fe2+ ions and you add hydroxide to it, it will form Fe hydroxide with two hydroxide groups on there. But in the air, so this will be a white-green color, this will oxidize to this one here anyway, which is the brown-red. So it'll start white-green and then go to brown-red, or it'll start brown-red. So if it starts whitey-green color, it's Fe2+. If it starts brown-red, it's Fe. We'll add some acid to it, a very strong, a fairly concentrated acid. We then take some of this out and we add it on a spotting tile. We'll add a few drops of potassium hexacyanoferrate reagent. Now, this will react, and dark blue color gives us Fe2+. So if it reacts and gives us dark blue color, it means we have Fe2+. We'll add some more drops on a white tile, and to that, so more spots on our spotting tile, we'll add a drop of potassium thiocyanate reagent, and this will give us a blood red color if it's Fe3+. So that's our confirmation test. All right, that's it. Here is our flow chart to show through how the whole thing works. You can see that we must go off in this direction, but we can also do the separate tests here, so you can see that it actually splits into two different ways. And that's it. That's our test. That was a long one. Hope you hung in there. It will make more sense when we actually do these tests in class next lesson.